Hello friends, in this video we discuss another interview question which is very frequently asked. What is a MAC address and how is it used? So to see what a MAC address looks like, go to your Windows command prompt and type this command. You'll see many entries and please point out or notice the entry with the tag physical address. So MAC is also called media access control address. It is a unique number used to identify a network adapter over a LAN or a local area network. It is also known as the physical or hardware address. In other words, like IP address is unique, MAC address is assigned to your Ethernet adapter card. The physical card which allows you to insert your LAN cable into the jack. That card has a unique number assigned to it which is called the MAC address. MAC address is also assigned to your Wi-Fi adapter card. Now we need to understand how a MAC looks like. A MAC address typically looks like MM with a colon, so it's a 6-byte address or 48-bit address. To understand how MAC address is useful in communication between two machines, we need to first understand how the data flows through the 7-layer OSI model. So here I represent two machines A and B. Both are connected to each other, and I have mentioned the 7 layers of the OSI model. So let us say machine A is trying to communicate with machine B. Data flows right from application layer in machine A through presentation layer, then through session layer, transport layer, network layer, data link layer, and physical layer. At the physical layer, this data is converted into bits or binary form, and it is transported over the network to the physical layer of B. Here the data again starts its upward journey through the physical layer, then the data link, network, transport, session, presentation, and application. Now, if you look at A, as data passes through every layer, each layer wraps the data packet received from the layer above it with its own headers and footers and some more information. So when the layer passes from application to presentation layer wraps application layer data into another header and footer. When the presentation layer data passes to the session layer again wraps a layer on top of it containing header and footer. The same goes for transport layer. The same goes for data link layer. And when the data arrives at B, at each level, the corresponding layer is removed and this data is read. So for example, as the data moves, the first layer at the physical layer, the bits are received. At the data link layer, the layer which was wrapped by the data link is removed, read, and transferred to the, because beneath the data link layer was the network layer data. And after removal of the data link layer data, the packet, the remainder is passed on to the network layer. The network layer reads its data, removes the wrapper, and passes the remainder to the transport layer. So each layer, in other words, just interacts with its corresponding. So the data packet created by the session layer will simply be read only by the session layer in B. It will not be read by any other layers. So that is how the whole flow of data through various OSI model layers works. Now here, why it is important is because MAC address comes into picture at the data link layer. So when the data is getting transferred from network layer to data link layers, an IP address actually comes into picture at the network layer. So as we know, to communicate through any system, we first need the target IP address. Network layer wraps the data it received from the transport layer and inserts a target IP address into that packet. When that packet comes to the data link layer, the data link layer needs to know the MAC address to which this data is getting transferred. So what the data link layer does is it sends something called as an ARP request, also called address resolution protocol. So data link layer sends an ARP request over the network, over the LAN network, asking who has this particular IP address, which is the target IP address, which was set by the network layer. The system or the machine which has that IP address responds to the data link layer with its MAC address. And that is how the data link layer knows to which Ethernet or network card the data is being sent. So data link layer will receive the MAC address of that particular machine. It will wrap the data received from the network layer into another packet, mention the target MAC address, and send the data to that machine. This example that we saw consists of two machines A and B which are physically connected to each other. That means they are connected through a LAN cable or a Wi-Fi network, but they are physically connected and are on the same network. There can be thousands of machines which are physically connected to each other. So the data link layer, to obtain the MAC address of B among all the systems which are connected with A directly, it will send the ARP request to all the systems connected to A directly, and only one system which will have that particular IP address. Since on a network there can be only one system with one IP address, so IP address over a network is unique. So only one system which will have that IP address will respond. So the query that data link layer will send is, please respond the one who has the target IP address of this. Only one system with that target IP address will respond back with its MAC address. That will become the target MAC address. Now, this address resolution protocol is nothing but a table which maps IP addresses to MAC addresses. So over a network, each IP address will correspond to a MAC address. Once the data link layer receives the MAC address, it caches it, it stores it, so that the next time when it has to send a data to that particular IP address, it already has the MAC address, so it doesn't need to send an ARP request. Now let us see, when over a LAN, when all the systems are connected through a router, how does the communication work? So here again, you see we have drawn two machines, A and B, and all the 7 layers in both the machines. Now these both machines are connected through a router. Now when data needs to get transferred across the layers, so first we need to know the IP address. So let us say the IP address of A is 192.168.1.35 and B has an IP address of 192.168.1.56. Now A needs to send the data to B. So in the network layer will get the data from the transport layer, and network layer will wrap that data in a packet. And in this packet, network layer will set the target IP address. which is 192.168.1.56. When this data comes to data link layer will generate an ARP request, send it to all the machines which are physically connected to it. So the machine which is currently physically connected to it, or the network adapter which is physically connected to it, and the network adapter currently connected to it is the router. So it will send an ARP request. This will send an ARP request to figure out who is the guy who is connected to me and has a target IP of 192.168.1.56. In fact, when the ARP request goes, nobody will respond. So when nobody will respond, then what the data link layer will do is, data link layer will send that packet with the target MAC address of the router. So if nobody responds to the address resolution protocol request, the data link layer doesn't receive a target MAC. It sets the next level router's target MAC address into the packet of data. So data link layer packs or wraps the data which it received from the network layer into another wrapper and sets the router's MAC address as the target MAC address. This data is received on the router end. Again, router has these three layers: physical, data link, and network. And this is physical. So again, the router has these three layers. The data is received by the physical layer, sent to the data link layer. Now data link layer unwraps the wrapper which was set by the data link layer of A. It figures out that the target MAC address was his own, so accepts that packet and sends the remainder packet to the network layer. Now the network layer identifies that the target IP address is something else, so it again sends back the packet to the data link layer. The data link layer now again sends an ARP request, and the request says, whoever is physically connected to me and has a target IP address of 192.168.1.56, please respond. Now since machine B is physically connected to the router, machine B responds to the router's ARP request. Now machine B sends its MAC address along with the response. So once the router receives the MAC address of machine B, the data link layer of the router wraps that packet with the target MAC address of B, sends it to the physical layer, and this data is transferred to B, where again the same process of transferring data and unwrapping the data through each layer takes place. So this is how typically a MAC address works, and you need to understand that one of the another important things which we discussed in this was ARP, which was address resolution protocol. And every time a network card or network interface card actually sends an ARP request and it receives the MAC address, it caches the MAC address. So next time it receives a target IP address, in its tables it will have the corresponding MAC address because it will store it. And thus we also saw how the data flows through all the layers of the OSI model, what an ARP request is. In a router, typically how the layers are arranged, it doesn't have anything above the network layer typically. When A and B are far apart, they are connected by many different routers in between. This process again goes through multiple hops. So if there is another router in between, this router and B, then data link layer will send an ARP request, nobody will respond, and it will send this packet to the next router's MAC address, and then the same process of ARP requests will happen. So this is how typically a MAC address works, and I hope you enjoyed the video. You learned something new. Thank you for watching. Have a great day.